Okay, everybody, let's talk a minute about the next section of work, which is Chapter 2, Section 6 in the book, Combining Functions and Composite Functions. So your book actually calls it the Algebra of Functions as well. And basically what we're going to talk about is you can have your functions well-defined, we hope. So you've got f of x, for instance, equals, I'm going to do x minus 5. And we can have g of x equals, let's do 2x plus 1. We'll start out with some relatively decent, not too complicated problems. So I've got those two functions. And when I look at them, they have the function notation in front of them. So I know that the teacher or the book or somebody thinks that they're functions. You can double check it if you want to, plug in a couple of x's, see what you get out as y's. And last week, we talked about functions. Domain of functions. So we can look at these and see, are we going to run into any kind of problems with the domain? So is there anywhere, if you'll remember, where we are dividing by something with an x in the bottom normally, and we could make that be division by 0. If you are, then that division by 0 produces a bad spot in your domain. Or are we taking an even root, like a square root of a negative number? Again, that's an imaginary answer, and while we can find those answers, we cannot graph those on the real number line. So we can't actually come up with what that solution is. So when we look at those, we say, okay, these two functions, okay, this is just x minus 5. That's just a binomial, and it's linear. I know it's linear because the exponent on that x is a 1. And this other one, g of x, is 2x plus 1, again linear. There's an exponent of 1 up there. We don't write the ones, but if it was a 2 up there, we call it quadratic. If it was a 3, we call it cubic and that kind of stuff. So these are both linear equations. I'm not dividing, so I don't have to worry about division by 0. And I'm not taking a square root or a fourth root, so I don't have to worry about taking an even root of a negative number. So when I look at that, I say, oh, the domain for f of x is all real numbers, right? Or if you were doing interval notation, we would say it's negative infinity to positive infinity. Or if you were plotting that on a number line, I usually use 0 as my place. I would say there are no bad spots anywhere on this number line. So all of those work. So if I pick, for instance, x equals 6 and put it in there, 6 minus 5 is 1. I'm only getting one output, I'm okay. And the same is true for g of x, right? All real numbers. And negative infinity to positive infinity. So there we go. We're not concerned about that. But whenever we start getting into doing algebra on functions, algebra of functions, what your book calls it, that's when maybe we start having some issues. And we're going to see how we're going to do combining these functions. We're going to start with these two linear ones, and then we'll get stuff that's harder. So the things that we might do look like this. F of x plus g of x. That would be adding the two functions. F of x minus g of x. Subtracting the two functions. Sorry about that. F of x times g of x. Multiplying, of course. And the last one is f of x divided by g of x. And in your book, what you see is that's the math we're going to do, but they kind of sometimes try to make it into smaller things. So f plus g of x. Basically, they're saying there are two functions, one's f and one's g, and they both have the variable of x in them. So what we're going to do is we're going to add those two functions together. As long as the variables are the same, well, even if the variables weren't the same, but when the variables are the same, I'm probably going to be able to combine like terms. I can still add two functions if they don't have the same variable, It's just very difficult because then I start going, well, I've got X's and Y's in here running around. And the same thing here, f minus g of x is the shorthand you'll see there. F times g of x, we're multiplying the two functions. And sometimes you'll see f divided by g of x. And that's what I see in your book. It's on page 301. So that's the shorthand notation they've got for that. So we'll just, whenever we see those, we will be okay. The one I want you to watch out for is this last one, because that's got division in it, right? So even though I've got these two really nice linear functions up here, and they've got a really nice, pretty domain, when I divide them, I might, well, I know I'm going to end up with stuff on the bottom, and I'm going to have to watch out for dividing by 0, right? So we're going to have to watch out for that. So let's run through these functions, the algebra of functions, as it were. And let's do f plus g of x. Oh, sorry. F plus g of x. Or f of x plus g of x. Okay. And we know that we had it up here. I'm going to rewrite them. F of x was x minus 5. So instead of f of x here, I'm going to substitute in x minus 5. Oops, does everybody see where I got that? Because they want me to take the f of x plus the g of x. So I come up here, I find my f of x. It was x minus 5. So that's what I'm going to place in place of that f of x is the x minus 5. So I plug that guy in. He just writes right there. And then I'm going to pull down plus. And notice that just habitually, I am putting parentheses. Anytime I go to replace stuff, here I'm going to replace the g of x guy. When I go to replace that, I want to know where it goes in the overall picture. So I just put parentheses. I put parentheses around the x minus 5. I'm okay here because it's just a plus sign. But what if this was minus 3 times g of x? Then I'd have to distribute that negative 3 through, right? So just habitually, I always put the parentheses. You can be a little lax with that, but really, really watch out for negatives, or if you're subtracting the two functions, you're going to have parentheses, or when you're dividing, sometimes weird things happen, so just watch out for that. Okay, so I need to know what my g of x is so that I can substitute that. So here I see g of x is the same as 2x minus 1. So I'm going to take that guy and I'm going to put him in down here, right? So g of x was 2x plus 1. All right. And again, addition is the function that's kind of nice to me. So it's not messing with my signage or anything like that. My pluses and minuses stay the same. So I can drop the parentheses and say x minus 5 plus 2x plus 1, right? So addition's kind of nice to me. So that's good. And now I'm in here and I look and I say, is there something that I can combine? And hopefully you see, well, there's an x and there's a 2x. Those are the same variable. So x plus 2x is 3x. So we can do that. That's good. And then hopefully you also see I have this negative 5 and plus 1 guy. So what's minus 5 and plus 1? Minus 4, right? Negative 4. So what I have here, when I finish, and I didn't write it here, but it was f of x plus g of x equals. When I finish right here, I've got f of x plus g of x equals 3x minus 4. Okay. So that one's not terrible because it was addition, right? Let's see, I have managed to mark all over my paper whenever I did that error. So let me go back. Sorry. Here we go. All right, let's talk about the subtraction. Again, remember f of x was, and I'm sorry, this is my first example. That we're working on. F of x was x minus 5, g of x was 2x minus 1 or plus 1. Just kind of keep those around just in case. Let's do the subtraction case. So f of x minus f minus g of x. Which one goes first? Well, it depends on which one's in the parentheses first, right? I hope you said that out loud. F comes first, so the f of x is going to go first. So this should be the x minus 5 minus, because we're doing subtraction, right? That's the operation in here. And then the g of x goes second, but be super, super careful here. You do need the parentheses because I'm subtracting all of that g of x guy, right? Which is the 2x plus 1. That's why I'm writing that there. So when I subtract that whole thing, remember that you're going to have to take this negative sign and distribute it through. Okay, so this is going to equal x minus 5. Those are okay. I can drop those parentheses, right? Because there's no minus out in front of them. But here, when I go to drop the parentheses, I've got negative 2x. So minus times a positive. And then I've got a negative times a positive 1. Oops, sorry, which is a negative 1. Sorry, I had to scribble that plus sign. All right, so now look at this. What do we got? We have an x and a negative 2x. Well, earlier that 2x was positive. So now this is going to mess with my signage, right? So what is a positive x minus a 2x? And in my head, I hear you saying, it's negative x, Dr. Webster. And then here I've got a negative 5 and a negative 1. Those are both negative. So we're going to end up with negative 6, right? You've got that. If not, go back and look. Remember, it's negative 5 and then negative 1. So they're all negative. So we just add on top. So add the values, keep the negative sign. So that's what's going on when I subtract these two functions. If that makes sense. Multiplying them, f times g of x. F times g of x is, well, the f of x is the first one, so I'm going to write him x minus 5. Again, I'm putting the parentheses because I want all of that multiplied times all of the g guy, right? So I put parentheses again. It's going to be one big distribution, or you might say FOIL. Some people like to call that FOIL. So g of x was 2x plus 1, right? So this was my f of x times, this is my g of x, okay? So then, like I said, you're just going to multiply that through. Well, it's the x times the 2x and the x times the 1. So whenever I look at that, x times 2x is 2x squared. And x times 1 is a positive x. Okay. And then on the inside, we distribute the negative 5 through. Negative 10x. And negative 5 times 1 is negative 5. Okay. And this should look something like some of the factoring stuff that we did before. The 2x squared has to stay by itself, but the x and the minus 10x, those are like terms and those can be combined, right? So this is going to be 2x squared minus 9x, and then the negative 5 is just a whole number there, an integer, and he can just be brought down, right? There's nothing I can combine those with. So once I'm finished simplifying this and combining my like terms, that's my answer. All right, and then the last of the 4 is the division one. So this is the one I want you to be super careful with, because whenever you put together this division process that we're going to show here, whenever you do that, we're going to have to watch out for domain, always. So which one goes on top, the F or the G? Well, when I look here, the F is on top, so I want the F on top, right? So remember, F was x minus 5. So I'm going to have a fraction bar, and on the top here, I'm going to write x minus 5. And then the G is on the bottom. Hope everybody's okay with that. And remember that the G was 2x plus 1. Okay, so this is my answer. I actually don't have to do anything to simplify that. There's not a way to like do anything crazy to get the x's on top. So that's my answer. So this is actually less math work as far as that's concerned, but then I have to worry about this denominator. I'm going to worry about domain. Are there any bad spots? And once again, remember that the two things you're looking for whenever you're looking at for bad spots in your domain, the one is if you're dividing by 0, and the other is taking an even root of a negative number. Gives you imaginary numbers. That would put a hole in your real number line, okay, with my solutions. So absolutely, I have to worry about this denominator. So 2x plus 1 cannot equal 0, right? I can't divide by 0. It can be anything else down there. So if I put in, for instance, a 3 here, 2 times 3 gives me 6. 6 plus 1 gives me 7. I can divide anything by 7. That's okay. But what I can't do here is I can't, whatever this is, I can't put that in. We'll see how that looks. So 2x plus 1 cannot equal 0. This is just an inequality. We solve it like we've been doing. So 2x cannot equal -1. And to get the x by itself, I'm multiplying by 2. So I come through and I divide by 2. Those will go away. And I've got that x cannot equal -1/2. Okay. So you always have to check whenever you have that fraction and make sure you know, is there a bad spot in the domain? And yes, there is. The bad spot in the domain would be where x was equal to -1/2. So we specifically say, hey, x can't be -1/2, right? That's why I tell you to go ahead and set it does not equal. If you'll go ahead and set it does not equal, then this tells you exactly where your bad spot is. X cannot equal -1/2, and you're done. X can be anything else as long as it's not -1/2. Let's see why. Okay. When I have -1/2, if I have 2 times -1/2 plus 1 on the bottom, and then let's just go ahead and stick it on the top just for fun. -1/2 minus 5 on the top. When I look at that top, that's okay. This would be f over g of -1/2. That's what we're finding here, okay? That's okay. What do I have on top? -5.5, right? Who cares? We don't care about that number. It's fine. It's legitimate. The one that we're going to be worried about is on the bottom, because when I multiply 2 times -1/2, I get negative. The 2 divided by 2 is a 1. -1 plus 1 is 0. And if you go to punch that on your calculator, it's going to tell you you have an error. Okay. So that's where I'm in trouble. So I can put in any other value I want here. Okay. I put 3 earlier. I had 7 on the bottom, 3 on the top. 3 minus 5 would be -2. What if it was a 5? 5 would give me a 0 on top, right? I'd end up with 0 divided by 11. And some people that bugs. But what is 0 divided by 11 if you punch that on your calculator? 0 divided by 11, still 0, right? That one would be okay. Even though it gives you a 0 on top, you don't care. The bottom is what you focus on. You can't divide by 0. It can't go on the bottom, okay? So that's where that is. Those are the 4 different operations you may be asked to look at. So I'm not going to do all 4 of them, but I'm going to give you an example for you to kind of play with and look at. And then I'll come back and talk to you. So the example out of your book, where they want you to look at this is, what if f of x was 2x minus 1, which is funny. I think that's one of the ones I just had, right? Oh, it's closed. I had 2x plus 1. This one's 2x minus 1. And if g of x is x squared plus x minus 2. Okay. So these are definitely different functions than what I had before. One is a quadratic. That means that, like, if I was to graph that, I would have a parabola. Okay. This one is a linear. They're both functions. No problem. So on your own, if you would like to practice this, f of x plus g of x, f of x minus g of x, f of x times g of x, and f of x divided by g of x. Okay, or you can use the notation they use in the book, whichever you prefer. So I'm going to skip that process. If you want to work it through, you can. I'm going to just go ahead and tell you what the book says the answers are. And if you have questions and you want me to work through them, or you can work through them with classmates, let me know. So the book says the first one is x squared plus 3x minus 3. And the second one, the subtraction, is negative x squared plus x plus 1. Okay. And then the multiplication is 2x cubed plus x squared. I'm looking, they've got some simplification stuff going on. Minus 5x plus 2. And I want you to think, does that make sense to have a 2x cubed in there? It should, because when I multiply this guy, he's got an x in him. And I multiply this guy, he's got an x squared. So x times x squared is going to give you the x cubed, right? So that makes sense that it's in there. And then the last one that they've got there, they said just simply 2x minus 1 over x squared plus x minus 2. That's the division. You don't have to do anything with that. But then they go through and they look at the domain and they say the domain goes from negative infinity to negative 2, or negative 2 to 1, or 1 to infinity. So I actually want to look at that one and make sure we're all good with that. So and what this is telling me is there's a bad spot here at the negative 2, right? So x can't be negative 2. And there's another bad spot here at the x equals 1. So x can't be 1. So that's what they're telling me about my domain. Okay, so let's see if we can corroborate that. This is coming about because of the division, and we want to make sure that it's not 0, right? So remember what we do, we pull that guy out. We say x squared plus x minus 2 cannot equal 0. Now I need to solve this thing. And whenever I go to solve it, I need to see if it'll factor. And I believe it will. So when I look at this, factors of 1 times negative 2, factors of negative 2 that multiply together to give me negative 2 would be a positive 2 and a negative 1, right? To give me a plus 1 in the middle. If you're not sure about that, go ahead and work with it and make sure. If you can't factor it, then put it in the quadratic formula. That will always work. All right, so now I have 2 factors down here. These are linear. Those are easier to solve. That's why we want them to be in that format. So I know x plus 2 cannot equal 0, or x minus 1 cannot equal 0. So x plus 2, I go to subtract 2, subtract 2. X can't equal negative 2. Or here I've got x minus 1. So to get rid of the subtract 1, I do plus 1, right? That's the opposite on there. These guys go away. X cannot equal 1. Well, look, that's exactly what they had, right? So hopefully that makes sense how they came up with that. All right, so that is whenever we're add, subtract, multiply, and divide these things. So now we have to do something called compositions. So just one, well, you can do compositions two different ways, either direction. I'm not going to get focused in on going both of the directions. If you can do it one way, you can do it the other way. So I'm not too stressed out about that. So what I'd like to do is first I'm going to explain the function composition notation. Then we'll do an example. Okay. The composition notation looks like F composed of G, where the composed of is this little circle in the middle. It kind of looks like a degree mark. So I always call that fog. F of g of x, f composed of g of x. So what that means is you take your function f and literally you're going to put into it the g of x. So instead of x being inside of the f, we're going to take the one function and we're going to shove it inside of the other one. Okay, so we're going to stuff it in there and then we're going to see what that does to it. And sometimes it does kind of interesting stuff to us. So f composed of g of x. So to do this one, oh, let me go ahead and show you the other notation just so you can see it. So the other one is g composed of f of x, and I call that one golf. And it's, like I said, exactly the opposite, right? So we're going to take the f function and we're going to shove it in and stuff it inside of the g function. Sometimes some of these compositions are easier to make than others because sometimes we make the math really hard whenever we do these compositions. So we say f of g of x, f of g of x, or f composed of g of x. Okay, it's going to be a substitution process. That's what we're going to see. So let me show it to you. We're going to use the first example that we had, which was f of x equals x minus 5, and g of x equals 2x plus 1. Okay. And we're going to do fog, f of g of x. F of g of x. And notice that you can use either of these notations you want, but to me, the one with the parentheses makes more sense. It's more intuitive, I think. So if we normally have f of x and x is my variable, then what I'm saying is instead of putting in a variable x, we're going to take the function and put it in there. So seriously, what we're going to say is, look, I need g of x. Okay, g of x is here. I want to make a substitution. Grab everything that's equal to g of x and put it in there. Okay, so I feel like the parentheses one is the easier one to understand because it just is, in my opinion, more intuitive. But if you like the fog notation, you are welcome to use that. It is absolutely okay. So what does that mean that I'm shoving the g of x in there? That means normally I would see an x here, right? But I'm seeing a g of x there. Okay, so go to your f function. Your f function is x minus 5, right? And I'm going to substitute in, let me use my arrow again, where I see the x, I'm going to substitute in whatever is equal to g of x. And we said that's 2x plus 1. So I'm going to substitute that in. Now this minus 5, he's just along for the ride. I put the parentheses just in case I have to distribute something or weird things are happening. Like if this had been minus 5x, then I'd have to put the parentheses there because I'd need to distribute the negative 5, right? But for now, because the minus 5 is at the back side, I don't care about that. So what I have is 2x plus 1 minus 5, or we know 2x minus 4, right? Okay, so that is exactly what we're looking for there. That's f of g of x. Let's go the other way just so I can say I showed it to you, but and some of your homework will say do both. So the g of f of x guy is exactly the opposite, right? It says instead of the x guy, wherever you see x, you're going to cram in that f of x. So let's come here. Here's my g of x. It's 2 times something, put your parentheses, plus 1. And here the parentheses are going to be important, right? Because the 2 is multiplied by it, which means I'm going to have to distribute. Okay. 2 times something plus the 1. That's what the g of x guy looks like. Where I just need to figure out what am I substituting in for the x now? Well, what I'm substituting in is the f of x, right? So go up there and find your f of x. Here he is. That's it. And find what it's equivalent to and substitute that in. So this guy, I'm sorry for all the arrows. This guy is the one that's going to come down in here. So instead of x here, I'm going to write x minus 5. So substitute that f of x guy in everywhere you see an x. This is only one of them, but it could get more complicated. So the 2's on the outside, I need to distribute it. 2 times x is 2x. 2 times negative 5 is negative 10 plus 1. 2x, negative 10 plus 1 is negative 9, right? Okay, there we go. Both of those were decent. Again, at the end, I'm going to look at it and say, there's nothing that's going to cause me any issues in my domain. So I am okay there. That's what we're after. So again, pretty quickly, we're going to do the other example. And I'm going to show it to you. It was, I'm trying to find my functions again. Sorry. Other example was f of x is 2x minus 1. G of x is x squared plus x minus 2. Let's do, I want to do this time the g of x guy. And the reason why I'm putting him first is because I'm running low on time. And he has the square in here. So I want to talk about what we're going to do with that square. Okay. So g of f of x, ignore the f of x right now. Just come in here and say, what does this function look like in terms of x's? Well, there's something being squared, and then there's that same something, and then we've got a minus 2, right? So I'm going to put parentheses, something being squared. That's going to take the place of this x, plus something, put your parentheses. That's going to take the place of this x, minus 2. And what is taking the place of the x? Instead of x, I'm cramming in there the whole entire function f of x, right? So here was my f of x. Here's what the f of x is equivalent to. That's what I'm going to slide in to my parentheses. Okay. So instead of x squared, it's going to be this whole thing, 2x minus 1 squared. And instead of plus x, it's going to be plus parentheses 2x minus 1. And then the minus 2 is just kind of along for the ride. He just sticks back there. No problem. So the reason I want to do this one is because of this little parentheses squared thing going on here. Because a very, very common mistake here is when people say, I see that squared. I'm going to do 2x squared and I'm going to do minus 1 squared. And that's not what's going on here. So remember that squared means that whole thing times itself. So what I really need to do is I need to write it out. 2x minus 1 times 2x minus 1. That's what 2x minus 1 squared looks like, right? This is this. Those are the same. Okay. If you don't write it out, then you stand the risk of losing your middle term. It happens all the time. So I really want you to watch out for that. So rewrite it. I know it takes an extra line, but it's worth it if you don't make mistakes. And then I'm just copying everything else down, the plus 2x minus 1 and the minus 2. All right. And now, excuse me, I've got a binomial times a binomial. How do I multiply those? I'm so sorry. Let me get a drink real fast. What happens when I talk for a long time? I'm hoping you're saying, I'm going to FOIL those, Dr. Webster, because that's what I'm hearing in my head. Excuse me. I am so sorry. All right. So there we go. And when I FOIL that, 2x times 2x is 4x squared. Minus 2x minus 2x. Negative 1 times negative 1 is plus 1. And then here, this is just a positive on the outside, so I can just pull this stuff down. I don't have to distribute anything in that second set of parentheses. Excuse me. If that original function had been minus x here, then I'd have to distribute that negative through, right? But I don't have to, so I'm not going to. All right. So here we go. We have a 4x squared. It's the only one with a square, so I'm good. I have a negative 2x and a negative 2x and a positive 2x. And I know that one of those negatives and one of those positives will go away. And that gives me negative 2x. And I have got a 1 and a -1. Those are opposites. So those are going to go away. And what's left over is this -2 that's sitting out here at the back, right? So -2. If you wanted to, I see that there's a 2 in each of those terms. You could, of course, factor that out, but I'm not going to. I'm just going to do it just like that. So I just know that I'm running out of time, and I apologize for that. I'm looking at it and I say you can do the f of g of x on your own if you want to. And let me look real quickly in the book and see if that's in there. I don't even remember where I got this from. They did not do the fog and the golf with those two functions, so I don't have that answer. I'm sorry. So if you want the answer, shoot me an email and I can find it for you. Just realize that you're going to do the f of x, put in the g, and then simplify that, right? So you're going to have to distribute the 2 all the way through. It shouldn't be too rough, but if you run into something you're not sure about, let me know. All right, I see in this section there are also some application problems. That just means word problems. So I'm going to go ahead and say we're done with this, except for word problems. And if you want to see some word problems, I can tack those on next week when we're actually on Zoom. So just ask me and I can grab a word problem. Okay. All right. I hope that helps. Have a great weekend, I guess I should say. See you later.